Hello, welcome back to my channel Fasehakem with ShynMiss. In this lesson, we are going to look at the reactions of alkanes. Alkanes are generally unreactive, but they undergo combustion and substitution reactions. First, let's look at combustion. In enough supply of oxygen or air, alkanes undergo complete combustion. But with limited supply of air, it undergoes incomplete combustion. Complete combustion, or when there is enough supply of air, alkanes burns to produce carbon dioxide and water. However, in incomplete combustion or in a limited supply of air, instead of carbon dioxide, a toxic gas carbon monoxide is produced. And if this carbon monoxide is inhaled, it can bind with the hemoglobin and produce carboxyhemoglobin. And this is an irreversible reaction since it interferes with transport of oxygen around our body. Now, let's look at some examples of combustion. In this example, methane reacts in enough supply of oxygen to produce carbon dioxide and water. Now, let's write this equation. Methane, CH4, is reacting with oxygen and it produces carbon dioxide and water. Remember that we must have same number of atoms on either side of the equation, as atoms are not destroyed during a reaction, they are just rearranged. I'll do a separate video on balancing equations. So for now, remember complete combustion of alkanes produce carbon dioxide and water. Now pause the video and try to write the equation for combustion of propane. Combustion is burning in oxygen, so O2, and complete combustion produces CO2 and H2O. Now, let's look at incomplete combustion of ethane. Ethane, when reacted with limited supply of oxygen, it produces carbon monoxide and water. Now, let's write down this equation. So, C2H6 plus O2 gives CO plus H2O. Now let's look at substitution reactions with halogens. Alkanes undergo substitution reactions with halogens, and this is a photochemical reaction, which means it requires sunlight for reaction to occur. Let's look at this reaction. Reaction of methane with chlorine in the presence of sunlight. Here, methane is reacting with chlorine. Due to sunlight, this bond will be broken, and chlorine in its monoatomic form is highly unstable. So it will quickly substitute any hydrogen of methane. The removed hydrogen is again unstable and will form hydrogen chloride by reacting with chlorine atom. This is a substitution reaction because chlorine is substituting or taking the place of hydrogen, and it forms chloromethane and hydrogen chloride. As you can see, though there are two chlorine atoms in a molecule, only one hydrogen is substituted by it. For another hydrogen to substitute, it has to again react with another chlorine molecule. So this reaction, again chlorine will split, and chlorine will go and substitute any one of the hydrogen, and hydrogen will go and combine with chlorine atom. So chloromethane has reacted with chlorine and produced dichloromethane and HCl. And again dichloromethane reacts with another chlorine molecule and form trichloromethane and HCl. This goes on till all the hydrogens are substituted. So again, trichloromethane reacts with another chlorine molecule and form tetrachloromethane and HCl. Now, let's write these equations. So, as you can see, 4 chlorine molecules are used to substitute all the hydrogens in methane molecule, and 4 hydrogen chloride molecules are produced. Pause the video and write the reaction of ethane with chlorine. Let's draw an ethane molecule. It can substitute any hydrogen. So let's say this chlorine atom substitute this hydrogen, and hydrogen go and take the place of the chlorine atom. And we will get chloromethane and hydrogen chloride. Hope you have learned the reactions of alkanes. Next, we are going to start alkenes. So hit the subscribe button and press the bell icon to receive notifications. Bye-bye.